Hello everyone and welcome back to another Algebra 2 lesson for this summer course. Today is going to be Lesson 8, Exponents and Logarithms. This is going to be the last week out of our 8-week course. So after today and after you do the homework, that's basically it, and I hope you have a great rest of your summer. But we are going to end on a good one. Honestly, a kind of short lesson today, but a good one nonetheless. First, we're going to talk about exponents. So when we look at exponents, we're talking about stuff like 2 cubed, for instance, which he would write that out like 2 times 2 times 2, and 2 times 2 times 2 is 8. And then if, for instance, I had 4 to the 5th, it would be like writing 4 times 4 times 4 times, like 5 times. And your calculator can do this. Like, you don't have to write 4 times 4 times 4, like 5 times. You can actually just write 4 to the 5th power, and you'll get the same number. Now, the one thing I will say that, believe it or not, some kids mess up on, they'll say 4 times 5, and they'll say it's 20, when really 4 to the 5th power is a lot higher than 20. It's a lot higher than multiplication. I don't expect you to make those mistakes. I'm just telling you the stupid things I see kids do. Anyways, next I have the list of all the exponentials that I think you should have memorized so that you don't have to plug it in your calculator, you just know them. You'll notice that as the number gets higher, the numbers will get bigger and bigger even faster. And so that's why you'll notice as the number goes up, I ask you to memorize less exponents. So now, as a little quiz, I want you to cover up your papers. If you're watching the recording, I want you to cover up your paper as well. And I'm going to basically give you one from this list, and you're going to have to tell me what it is. Just think about it in your head. Don't say it out loud. Okay? We'll start with 2 to the 4th, and I'll give you a couple seconds to think about each one. The answer is 16. Next, 5 cubed. What is that? That's going to be 125 because it's 25 times 5, which is like 5 quarters, 125. And then one more, 3 to the 4th power. Well, 3 cubed is 27. 27 times 3 is going to be 81. So, again, I recommend having all of those memorized. If you don't, it's not a big deal. I just think you're at a disadvantage because there are going to be kids in your school who do memorize these. So, you might as well be one of them. So, next I want to talk about zero exponents. Maybe you've even known this fact before, but anything raised to the 0 power is actually 1. So, for instance, 3 to the 0 is the exact same thing as 105 to the 0. The answer is 1 for both. And there's actually a pretty cool proof that I can give you that explains this. Basically, if I have, like, let's say, a list of x and y values, like here's a list of x values, here's a list of 3 to the x values, and I think of 0, 1, 2, 3, etc. Well, 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27. In other words, each time I'm dividing by 3. There's a pattern here. And if I were to divide the next one by 3, well, 3 divided by 3 is 1. So following this pattern, it makes sense that 0 is going to be, well, 1, no matter what the number is. So you don't have to memorize the proof. You can just memorize the fact that anything to the 0 power will always be 1. Any questions on that first page? Okay, then great. Now we're going to talk about probably one of the hardest things in all of mathematics, which is understanding negative exponents. In my opinion, it's really easy, but clearly, based on the students I tutor, especially for calculus, they just don't understand it at all. Very sad. I'm going to assume it's because they didn't have a good foundation when they were in Algebra 2, so hopefully this will clear some things up so that you'll crush calculus or even pre-calculus. So when you have a negative exponent, just remember, negative exponents puts it in the denominator, or if it's a fraction, it's the reciprocal. Reciprocal means flip it, by the way. So let me explain what I mean. If you have 6 to the negative first power, that's the same thing as 1 over 6. See that? I just put it in the denominator. Now, if I have 12 to the minus second power, that's going to be a little interesting. It's going to be 1 over 12 squared. 1 over 12 squared. In other words, just the negative sign went away. You still have the squared to deal with. And we know 12 squared is 144. So it's going to be 1 over 144. Obviously, 12 squared was not on my list of squares. I'm assuming you know all the squares up to 12 at least, being 16, 25, 36, 49, 64, 81, 100, 121, 144. I'm assuming you know those. Anyways, next, 2/3 to the negative third power. This is what I was talking about earlier. If you have a negative exponent and it's a fraction, reciprocal. And reciprocal just means flip it. Flip it. So it's going to be 3/2 now to the positive third power. And you may be wondering, how do I deal with this? Well, first you can plug it in your calculator, but let's say you don't have a calculator. Then what you would do is you would apply this cube to both the numerator and the denominator. You apply it to everything. So really it's 3 cubed over 2 cubed. And hopefully remember from the last page that 3 cubed is 27 and 2 cubed is 8. Any questions on negative exponents? Hopefully that makes sense. By the way, one example I should have included but didn't. Let's say I have 1/4 to the negative second. In other words, it's in the denominator. Well, then you're going to put it back in the numerator. And so that's what that would look like. If it's already in the denominator, it goes to the numerator, and that would obviously be 16. Okay, any questions there? Okay, then now we're going to talk about the properties of exponents. We have 3 properties to talk about today. First is the multiplication property. Let's say you have x squared times x cubed. And the key here is that the bases have to be the same. If your bases are the same and your exponents are different, you just add your exponents together. In other words, multiplication, or I should say exponentials, just became, I guess it's multiplication because you're multiplying the things together. Multiplication became addition. That's what I'm trying to say. Anyways, it's x to the 5th for that example. Then if I have division, like let's say x squared divided by x cubed, instead of division, it's going to become subtraction. It's going to be x to the 2 minus 3 power, and that's going to be x to the negative first. Which we remember, x to the negative first, that's the same thing as 1/x, because negative power puts it in the denominator. Now, honestly, I'm okay today in this summer course. I'm okay with leaving it as the negative power. I'm also okay with you writing it like this. I don't care. Personally, I like the 1/x answer a little bit better, but they're both correct. And then finally for the power property. The power property, what we're going to do is we're going to say, let's say we have x squared and that whole thing is cubed. What would I do with this? Here's what I would do. If you have a power raised to a power, this is when you multiply your exponents together. So it's 2 times 3 power, and you'll get x to the 6th. Any questions there? Okay then. So that's all of our properties that we're going to be using on the next page. And now let's do 6 examples of what we're talking about. First one, 5 to the 4th times 5 cubed. All I'm going to say is multiplication becomes addition. So you've got 5 to the 7th power. And I'm not going to ask you to know 5 to the 7th. It wasn't on our list of memorization. Technically, you could plug it in a calculator, but I'm saying you can leave your answer in exponent form. That's what I say at the top. Next, 8 squared times 8 to the 0 times 8 to the minus 1. Now, technically, you can rewrite 8 to the 0 as 1, and you can write 8 to the negative 1 as 1/8. But let me tell you the fastest way to solve this problem. The fastest way to solve this problem is writing 8 to the power of 2 plus 0 minus 1. In other words, just add your exponents together. And that's going to give you 8 to the first power. 8 to the first power is just 8. The answer is 8. Any questions on that one? Okay. Can someone help me do number 3? What am I going to do for number 3? It's going to be, since it's division, it's going to become subtraction. So in other words, it's 3 to the 6 minus 12 power, which becomes 3 to the negative 6. And 3 to the negative 6, hey, that's a negative exponent. You can rewrite this as, not 3, 1/3 to the 6th power. But again, you can leave your answer like that as well. They're both correct. By the way, another way you can do number 3, because this is the way I used to do it when I was in high school, I would just say, hey, if you have 3 to the 6th and 3 to the 12th, the 6 cancels there, and the 12 cancels, leaving you with just 6. So you're only left with 3 to the 6 in the denominator. But if you don't like that way, you don't have to do it that way. I don't care. Next, number 4. Number 4, there's 2 ways you can do it. I'm going to show you both. The way probably I'd like you to do it is I would say 2 to the 6 over 2 squared, first reduce that in the parentheses. You will get 2 to the 6 minus 2 power. You'll get 2 to the 4th. And then don't forget, that's still raised to the 4th power. And then since I have a power raised to a power, I know I'm going to multiply the powers. So it's really 2 to the 4 times 4, which is 2 to the 16th. And 2 to the 16th, I mean, I have no idea what that is as a number, so I'll just leave it like that. Now, as I mentioned, there's two ways to do number 4. The second way, let me just rewrite it. The second way is to apply the 4th power to both right from the start. So in other words, it would be 2 to the 6th to the 4th divided by 2 squared to the 4th. And here you'd multiply both of them together. So numerator, 2 to the 24th power divided by 2 to the 8th power. And now you have division. You can just subtract them. It's going to be 2 to the 24 minus 8, which is 2 to the 16 power. It's the same answer we got before. I think this is a little bit harder with the math, so I prefer the other way first. Deal with the parentheses first, then raise it to the power last. Any questions with that one? Okay then. Why don't you try number 5 on your own then? And keep in mind, there's a negative exponent in the denominator. Think about how you're going to deal with that. So go ahead, I'll give you about a minute. Okay, I'm going to say time's up. If you're not finished, that's okay. But basically here with the x's, I'm just going to say, for the numerator, I add the exponents, so x to the 9 plus 5. And then I need to subtract the denominator, so minus negative 3. That will be a double negative, making it positive. So in other words, it's x to the 9 plus 5 plus 3. That's going to be 17. And so then the final answer is x to the 17th power. Any questions on that one? Okay then. And why don't you try number 6 on your own as well? Remember your order of operations. You got to do the exponents first, then multiplication second. Okay, I'm going to say time's up for that one now. And now if you want to do this one, first thing I do is the power raised to a power. So in other words, y to the 5th squared is going to be y to the 5 times 2, which is 10. And then times y to the 6 times 0 is going to be 0. Now there's two ways you can go from here. Number 1, it's multiplication. You add the exponents together. Some of you may have multiplied by mistake and you'll get y to the 0 as your final answer, which would be wrong. The final answer is y to the 10th. And then the other way you could have done this is you could have said, hey, y to the 0 is just 1. So it's really y to the 10th times 1, which gets you y to the 10th, the same answer. I don't care which way you do. They're both right. So that's it for this first page, and that's it for basically exponents in general. Any questions on any of those? Okay then. Next we're going to talk about logarithms. Maybe you've heard of logarithms before, maybe you have not, but either way I'm going to explain what a logarithm is, because even if you've learned it before, I almost guarantee you forget it by now, because believe me, it wasn't until college that I actually understood, or at least remembered what a logarithm was. So here's how you read a logarithm. Log base 2 of 8, and here's what you're going to do. By the way, there is a way to plug this in your calculator. You probably need a graphing calculator. Like, I only know how to do it on my TI-84. And if you want to do a logarithm, you would hit the math button, which is below alpha. Wait, is that not even right? There is a log button on the calculator. It's below, well, I guess it's below the x squared button. It's next to the 7, at least on my calculator. You'll actually see two buttons. You'll see the log button, and then right below that you'll see an ln, which stands for natural log. And then if you want to choose a different log base, you would have to hit the math button and then hit up twice, and you'll see the words log base, and if you hit enter, you'll actually see you can choose your own base. Now, I'm going to be explaining a lot more right now, because right now you still don't understand what logarithms are. So here's what a logarithm is. You see log base 2 of 8 here. Here's how it reads. I would say 2 raised to the blank power equals 8, and then you have to fill in the blank. Well, the answer is 2 cubed equals 8, so log base 2 of 8 is 3. Now we have a bunch of examples to look at right here. First, log base 3 of 9. Again, playing the same game. 3 raised to what power equals 9? I would say 2. So for that reason, 2 is the answer for number 1. Now for number 2, log base 6 of 36, same exact thing. 6 raised to what power equals 36? And again, it's the same answer. 6 squared is 36, so the answer is 2. And that's what we're going to keep doing over and over again. Like for instance, number 3, what would that be? Well, it's going to be 5 raised to the blank power equals 5. Who knows what that's going to be? That's just going to be the first power, so the answer is 1. And then number 4, log base 8 of 1. So we've got 8 raised to the blank power equals 1. Who knows what this is? That's going to be the 0 power. So the answer is just 0. Any questions so far? Okay, we've got a few more to do on the back, but before we get to the back, I just want to explain one more thing. And this is kind of like a fun fact. There's 2 logarithms that are very special. One is the common log, which is just, let's say, log of some number. Let's just say 8. And notice the base is missing. Whenever the base is missing, you assume it's 10. You assume the base is 10 by default. And you're going to use the common log, at least if you ever take an engineering class, you're going to use the common log a lot whenever you have things like decibels for sound. It's a way of measuring sound. You're going to use base 10 whenever you talk about basically anything that has an exponential nature to it. Another example would be like the Richter scale, which is how they measure earthquakes. That uses a log scale with base 10 by default. There's a lot of different things. Then they have the natural log. And the natural log is special. It's called ln. If you've ever seen ln before, it's the natural log. And that just means log base e of some number. I don't care what the number is, but it's base e. Now you may be wondering, what's the number e? Well, e is a special number. It's equal to 2.71828, and then it goes on forever just like pi does, okay? And if you're wondering where does e come from, I'll give you 2 responses to that. E is the number you get from the following equation, 1 plus 1 over infinity to the power of infinity. And you may be wondering, how on earth would you ever solve that? I would not. As a matter of fact, I don't even know how to solve it. But someone smarter than me by the name of Leonard Euler, who many, and when I say many, I mean like the math community in general, consider this man, Leonard Euler, his last name's pronounced Euler, not Euler. Many people consider him to be the greatest mathematician of all time. Not just because he discovered this E number, which many people think it's named after him, because, you know, the number E, he discovered it. But he also basically discovered a ton of contributions to mathematics that you and I both will never even come close to comprehending in our lifetimes. Even me, who's supposed to be really good at math, and I'm a math tutor. I don't understand a lot of this stuff, believe it or not. But anyways, log base e is a very special logarithm when it comes to calculus. And that's because e, the number e, is the most important number in all of calculus. So once you take calculus one day, you'll agree with me that e is a very interesting number, and you'll see why in a few years. But I guess this is more of a fun fact. You don't have to know this for today. I'm just telling you. Any questions there? Okay then. So continuing then with the next page. Next we have log base 2 of 16. So for instance, I keep playing the game, 2 raised to what power equals 16? The answer is, and this is by the way why it's so important to memorize that table from the first page, 2 to the 4th equals 16. So the answer is 4 for number 5. And now I'm going to give you about, I don't know, a minute 30 to do 6, 7, and 8 on your own. So go ahead. I'm going to say time's up just because these problems go pretty quick. So for the first one, 4 raised to what power equals 64? And the answer is the 3rd power. So the answer is 3. Next, number 7, 3 raised to what power equals 81? That's going to be the 4th power. So the answer is 4. And then for the last one, 2 raised to what power equals 32? That's going to be 5. So the answer is 5. See, when you really know your exponents, it's going to be really easy doing these problems. Okay, so that's it for evaluating logarithms. Now, just like how we had properties of exponents, we're going to have properties of logarithms. And this is some of my favorite stuff. This is a lot of like brain teaser kind of stuff. So first we have the multiplication property. Let's say I have the log of x, log of x times y. Two things multiplied together in the middle. That is going to become log of x plus log of y. Notice the two logs are separated, but there's a plus sign in the middle. Keep in mind, the reverse is not true. What do I mean by that? If I have log of x plus y, let's say, that does not equal log x times log y. In other words, if you have log of x plus y, that cannot simplify. Can't simplify. Okay? The only time you can simplify is if it's multiplication or division inside of your logarithm. Okay? So the division property. This is like if you have log of x divided by y, and you can probably guess it. It's going to be log of x minus log of y. Now, by the way, I put parentheses here because it's good notation. Sometimes I get lazy with the notation and I'll just write, for instance, log x minus log y. That's okay here because it's just one term. But if I had, let's say, something like log of x plus 1, then I would need parentheses, because if I didn't have the parentheses, I would be technically saying something else in math, and I don't want to do that. And then finally, the power property. This is different than the power property for exponents. Basically, if I have, let's say, log of x cubed, then what I can do is I can pull this 3 out in front, and I can write this as 3 log of x. All I did was I moved the exponent out in front. That's how you do the power property. Now, when you do the power property, here's two cases that might trip you up. Here's the first one. Log of, let's say, x plus 1 cubed. Well, again, this can equal 3 log of x plus 1 because I can move the power out in front. But here's something that's not true. Let's say I have log of x cubed plus 1. This does not equal 3 log of x plus 1. You cannot do that. You can only do that power property if the whole thing is raised to the third power. And remember, that plus sign really messes with us a lot of the times with our properties of logarithms. So, any questions on the properties before we do some practice problems? Okay then. The last page, I'm not going to lie, these are some of the harder ones. The hardest problems today are literally on this page. But hey, it's the last page that we're ever going to have together this summer. So, let's make it a good one. Number 1, log of x cubed times y to the 4th, and the goal is to expand the logarithms as much as possible. So for instance, I see multiplication. First thing I would do is say log of x cubed plus log of y to the 4th. And then you're probably already thinking it, yes, I can move the exponents out in front. So it's going to be 3 log of x plus 4 log of y. You'll notice all of the logs I've done recently have not had a base. Because I don't have a base, it doesn't mean base 0, it means base 10. And again, I don't care about that because I'm just rewriting it. But that's why I'm missing the base. It's because the base is 10. Next, number 2. Number 2 is tricky. First thing I would do is I would say I have division, so that's going to become subtraction. So in other words, log w2x minus log of t squared. And yes, you can pull the 2 out in front. I'm going to do that. But what about the 2wx? Can I break that up? Yes or no? The answer is yes. How would I break it up? We're going to break it up like this. We're going to say log of 2 plus log of w plus log of x, and then finally minus 2 log of t. And the 2 because that was the power. And there we go. There's our answer for number 2. You'll notice I can even split up the 2, like log base 10, I guess 10, but log of 2. Okay? So wherever I have multiplication, I can split it up. Wherever I have division, I can break it down that way. Now, number 3 is a fun one. There's 2 different ways you can do number 3. I'm going to be doing both ways, and then I'll tell you which way I like better. Obviously, when on the test, don't do both ways. Just do the one you prefer. But the first thing you can do is you can say, this is going to be, distribute the 3 out to both of these. Log of m to the 6th divided by n to the 4 times 3 is 12. Remember, this is the power to a power property from exponents. M squared cubed is m to the 6th, n to the 4th cubed is n to the 12th because of multiplication. And then I can just split this up by writing log of m to the 6th minus log of n to the 12th. And yep, you know it, I can rewrite this like 6 log of m minus 12 log of n. And now that's one way you can get that answer. Of course, the other way, well, first I'll give you a second to write that down. And then, of course, the other way you can get this answer is by saying, hey, I have that third power right there. Can I bring that out in front? Yes, you can. You can rewrite this as 3 log of m squared over n to the 4th. But then you still got to use division property. You got to subtract them. So it's going to be 3 log of m squared minus 3 log of n to the 4th. Notice the 3 goes to both of them because it's out in front. It's kind of like a coefficient. And then you can bring the 2 out in front to be 3 times 2 is 6 log of m minus, bring the 4 out in front, 3 times 4 is 12, minus 12 log of n. Now, I don't care which way you use. I probably like this way better, the second way. But if you like the first way better, you can do it that way as well. Any questions? Okay. Then we got one left, last problem of today. And after we do this problem, I am going to ask you to hang on because I have my end of the summer speech that I will be giving out. It's the log of 3ab to the 4th over 5c squared. I want you to think about this. Just think about it in your head. How would you solve this? You're probably thinking about splitting it up with like the numerator. You're probably thinking log 3 plus log a plus 4 log b. And maybe you're getting stuck on the denominator. Because what do you do in the denominator? This time we have 2 things in the denominator. Let me show you what we do. Actually, first I'm going to write it on a separate sheet of paper because this one's like really long. So make sure you have a lot of room horizontally because it's pretty long. Okay, so the secret is for this log is whatever you have in the numerator is a plus, whatever you have in the denominator is a minus no matter what. Okay? In other words, it's going to be log of 3 plus log of a plus bringing the 4 out in front, 4 log of b. And I can do that because all these things are multiplied together. There's no pluses or no minuses in the logs themselves. Now for the denominator. Since both the 5 and the c squared are in the denominator, I'm going to say this. Minus log 5 minus, I'm actually going to write that as 2 log of c because of that power property. But the most important thing is to remember that both of them get the minus sign because they're both in the denominator, and that's the rule. And just like that, we're done. Because I already took care of the power rule, so we're done. Any questions on that one? Okay then, so I told you it'd be a short lesson to end it with. I'm just going to tell you right now, next year I'm going to make these things longer because clearly I didn't do the best judge of time this time. But that's okay because, you get to get let out early and you still learned a lot of math this summer. So the last thing I want to say before I let you go is I want to remind you, why am I doing this all for free? Why did I have 8 summer classes? First of all, with you, with the Algebra 2 class, then with 5 other classes, Algebra 1, Geometry, Pre-Calc, Calc 1, and Physics. Why am I doing this all for free? If you remember from the very first lesson, like the first thing I told you was, I'm doing this for free because I want to become the greatest tutor of all time. And so even if this doesn't pay off in the long run, even if I get no students from you guys doing this, that's perfectly okay with me. Because the truth is, when I started Dan the Tutor back in 2020, no one knew who I was. No one reached out for me for tutoring. None of the schools would get back to me. No teachers would get back to my emails. And so what did I do? Well, I literally had to do what I'm kind of doing right now. I had to put together these online courses and I had to tutor for free. And for 3 months, I was tutoring for 6 hours a week on top of working a 40-hour-a-week job, engineering job. And I was doing this for free because I knew it would pay off in the long run. And so ultimately it did, because in the fall I had 14 students, and then in the spring semester I had another 16 students from college students, and I made thousands of dollars, and of course it paid off in the long run. But I'm not doing this for the money. Of course it's nice that I'm able to pay the bills doing what I love, but really it's because I want to provide more value to you than I'm asking in return. Because that, especially if you're starting from zero like me, that's what you gotta do. And honestly, when you do something that you love, it doesn't feel like work. As a matter of fact, when Monday rolls around, when the weekend's over and I go back to work every Monday, I don't feel any anxiety whatsoever because I know I'm doing the thing that I love to do. And on top of that, I tutor on the weekends anyway, so it's not even like I have a break. But really, what I hope for you more than anything else is that I hope you find something that you love to do 40 hours a week for the rest of your life. Because if you don't, you're going to be miserable, just like I was at my engineering job, and you're going to be wishing you were doing something that you did feel passionate about. And even worse, you're going to be getting beat by the people who do love your job, your coworkers, and they're going to be the ones getting the promotions and not you. So that's my lesson to you. That's my piece of life advice. And I hope you have a great rest of your summer and a great school year and a great college experience. So with that, I bid you adieu. Take care and bye-bye.